Good morning, good afternoon, good evening. Today I'll be showing how to make the Spline Morph Effect. Text will come apart as splines and will regroup to form another. It's going to be a combination of text forming spline and morph effect, but connecting and trimming the splines can be a little tricky. It is going to be a bit long video due to the sheer volume of nodes to cover. I'd appreciate it if you'd watch till the end. So buckle up, strap in, and let's get started. Alright, as soon as we get into Blender, we'll hop right into Geometry Nodes Layout. A to select all, X to delete, Shift A, add mesh plane. Using numpad 7 and 5, go into top orthographic view, click on new, delete group input, replace it with string input. Today I'll be using multiple lines, so I'll type in S/N, then B, then pass it through a replace string, find /n, and replace it with line break. Pass the result through strings to curve, then output. Alright, today's effect is going to be a spline morph, which will have a guide spline that's coming out of S and goes into B, and the spline that is forming this S will go through this guide spline and go into B and form the letter B. Alright, something like that. So let's first start off by resampling. Right, so let's add a resample. Change the mode to length and resample it with 0.01 meters. Next, let's separate out each line by using separate geometry. Change the domain to instance. Then pull out a compare equal. From line, connect to A, like so. Now we've isolated just the first line, so we only have S. Let's first realize this. Then grab these three nodes, Ctrl-Shift-D to duplicate with connections, bring it down, then set B to 1. What we'll have on the bottom is going to be the second line, which is just a B, and the top is going to be the first line with S. Right, so this S consists of one spline, whereas B is going to have two splines. The first rule of morphing is we have to match the number of splines. So let's go ahead and do that. Grab a domain size out of realize instance, change the component to curve, duplicate downwards, and connect it up. Then from spline count, get a maximum, maximum, and get the maximum amount out of these two spline counts. Okay. Right. So the result of this should be 2. And we're not going to be directly using these splines that's forming the letters. We will create a new curve object with 2 splines. So we'll first add a repeat, plug in the result of maximum into iterations, then add a join geometry, like so. Add a curved line, then connect it up into join geometry. Right. So if we take a look at here, we're going to have two splines going upwards, and we will use these to retarget to the shape of the letter. Okay. So first thing that we'll do is grab a resample. We want to match the count to the same number as the letter splines. So I'm gonna grab a line out of here and get a sample index, change the type to integer and domain to spline, then grab a point count, spline length point count, and plug it into value like so. We'll draw a line from sample index to count, and we'll grab these 3 nodes and Control G to group it. Right? Let's open up the side panel with N and rename this geometry to target. So this is going to be the target letter spline that we're going to retarget to, and this is going to be the curve splines that we just created. Let me move these around so it's easier to see. Okay. Here. Right. Maybe something like that. Okay. So, right now, like I said, this is a letter spline, and this is a spline that we're retargeting. But the problem is we have 2 splines we have to retarget to 1 spline of letter S. So let's start off by adding a for each element node. Change the domain to spline. Reconnect up like so. Right. Okay. So we will be retargeting both these splines. Right. We want to connect this index to this sample index right here, but like I said, this target only has 1, so we'll be lacking the target to retarget towards. So what we'll do is grab a line noodle out of this index and connect it to floored module. Then duplicate this target group input, grab a domain size, and change the component to curve. Then get the spline count to floored module like so. This way we'll always have spline target that these splines are going to retarget towards. So let's connect this up to index. And now what we'll do is set position. Okay. Let's grab the group input, duplicate it to the right. Let's get a sample curve. Grab a spline parameter factor and connect it to factor. Then we'll use a result of this floored module and put it to curve index like so. Then connect up the position. Alright, so we have both these splines. Well, we have 2 splines that's in a shape of S. Alright, let's clean it up a bit. Okay, so we are done with retargeting. Alright, let's tab back out. I'm gonna call this retarget spline. And let's duplicate this with connection using Control-Shift-D. Bring it down, and we'll change the target to the second line, which is going to be the B. Okay, so if we take a look at here, we have 2 splines that's retargeted to the shape of B, and we have 2 splines that's retargeted to shape of S. Right. So we'll also want to be using this line, and I'm gonna make a guide spline out of this one. So what we'll do is add a join geometry, and connect them up like so. Make sure you connect it in order, so it goes top, middle, bottom. These have socket positions within one socket, so make sure it's in order. And if we output, we have 6 splines, so 2 for each. So S has 2, this middle one has 2, and B also has 2. Right. So I'm gonna grab this join geometry and Control G to group it by itself. Open up the side panel with N. I'm gonna rename the input. The top one is gonna be the before spline. The middle is gonna be the guide, and the last one is gonna be the after. Okay. Right. So I want to start making the morph algorithm right here, but I don't want to be dealing with all 6 splines. I want to be dealing with one of each. So one of after, before, and guide. So let me just disconnect this first, and let's grab a separate geometry and connect up the before to geometry, change the domain to spline, and grab an equal out of compare and connect index to A, like so. Right. So now we'll reconnect it back to join geometry. So we now only have one spline that is forming the S. We'll duplicate these 4 nodes, bring it down, and change the input to guide. Then reconnect. Make sure you mind the order, and let's duplicate it down again and connect up the input of after to join geometry, then selection to here. Right, so it's all in order, and all of these now only consist of one spline. So we only have 3 right now. Okay, let me create some reroute to clean it up and maintain its cleanliness. Right. What we'll start to do is form the guide spline. Right. So we have this one that's going up and down, but we want it connecting like so, right? The way we're going to do this is we'll grab the end point of S and we'll connect the guide spline, well, start of the guide spline to end point of S, then end point of the guide spline to the start point of B. Okay, and we'll make it curve around. Right, so this middle portion is going to be the guide spline. So let's create some space. I'm gonna actually create some space here as well. And let's first start off by using a set position. Right. So we want to first set this position, which we'll first get an endpoint selection, and we'll set the end signs to 0 and start to 1. So we are just dealing with the starting point. Then let's grab a line out of the top one, which is a before spline. Grab a sample curve, set the factor to 1, and plug the position into position like so. So now the guide spline is connected to the end position of S, which is right there. Now let's connect it to B, which is going to be right here. So we'll grab these 3 nodes, duplicate it to the right, reconnect, and for endpoint selection we'll choose end size 1 and set the factor to 0, grab a line out of the after spline and connect it to curve, like so. Okay. So now S and B is connected via this guide spline, right? However, it's straight. I don't want it going straight. I actually want it to follow this end portion's tangent upwards, kind of like that, and curve around and go in following the starting point tangent going that way. Okay, so let's kind of do that. And to do that, I don't want to use the spline type of poly. I'm going to change the spline type to Bezier so we can use the handles. Okay, so let's use a set handle position to adjust the position of the handles. I'm going to set the handle to the right. I want to start dealing with this portion, so it's going to be the starting point. So I'm going to duplicate this end selection, bring it over, connect it to selection. Then using the tangent of the first sample curve, draw a line out of here, get a vector mass scale, and connect it to offset, like so. Okay, so now you can see the guide spline just following the tangent upwards and going down. Alright, let me just reroute a bit. And as a matter of fact, I'm going to create a bit more of the space. Okay, so the beginning portion is good. Let's get started with the end portion. So we'll grab these 3 nodes. Let me create some more space. Grab 3 nodes, duplicate to the right, reconnect, change the handle to the left, change the end point to end. Then from the second sample curve, grab a noodle, connect to scale vector right there. Well, okay. Right, as you can see, it's actually going the opposite direction, so let's scale it by -1 instead. So it comes around like so. Alright. So we got the guide splines connected like the way we want to, but it's a little jaggedy. You can see these edge corners, so let's change the spline type again. And this time we'll select NURBS. Right, so as you can see, we get this nice smooth curve going from S to B. Okay, right, so we're done with making the guide spline. So let me just select these guys, these nodes, Control G to group it, so we can save up some space. Let's open up the side panel and rename the inputs. The top geometry is going to be the guide. The next curve is going to be the before, and the last one's going to be after. Okay. Let me clean it up a bit. Okay. So this is how it looks. Alright, let's tab back out. I'm gonna call this make guide. Right. Let me clean it up some more. Okay, so we've made this guide spline, and it's connecting these 2 letters, but we still have 3 splines, right? So there's 3 separate splines. We want to combine it into one long spline. The way we can do that is, well, we can't do it in the curve domain directly, so we'll have to convert it to mesh first, then merge by distance, then convert it back to curve using mesh to curve. That should have done it, but well, it didn't. We still have 3 splines. The reason for it is because we have this merge by distance, basically merging all the points that applies. We don't want that happening. All we want to do is connect the endpoint of S and to the beginning point of the guide spline, and endpoint of the guide spline to beginning point of the after spline. So we will make specifications to which points we want to merge by making this selection. Okay, but before we do that, let me move this curve to mesh over this way so the operation is easier. Let me duplicate it down like so. So what we have now is, when we do the join geometry, we already have them as mesh instead of curve. Okay. Right, so what we want to do is specify which points, or the index of points that we want to merge. Right, so to do that, I'm gonna make a helper function. So let's add a capture attribute right here, and Control G to group it. Okay, right. So let's start at this point, right? This is where we want to merge. So what do we want to merge? Well, we want to merge the index, well, the point vertex index of X, which is going to be the last index of this S mesh, and we want to connect it to the guide, right? So the starting point of guide is going to be 0, endpoint is going to be X. So we'll make a helper function that basically identifies those points, right? So let's just take a look at S. So let's say this is going to be the, the starting point. So the index right here is going to be 0. We technically don't know what the index of this guy is right now, right? So let's make the starting point first. So grab an index and compare equal to 0, and that's going to be the starting index because it always starts at 0. So let's grab this and plug it into capture attribute, open up the side panel, go to the node tab, and call this is point st. So this is the starting point. Okay, so what's going to be the end point, or the last point? Well, we know this S consists of 203 vertices. So the last index is going to be 202, right? So 203 minus 1. So let's duplicate these two nodes, and also group input, bring it over, grab a domain size, and get the point count and subtract it by 1. Then compare it to the index. Then plug the result into capture attribute. Call this is point ed. Then we'll pass it to group output like so. Okay. Right, so this is a helper function to identify which points are starting and ending points. Okay, let's tab back out. And I'm gonna call this judge endpoints. Okay, I'll duplicate these downwards to both the guide and the after spline. Then, starting with this point, I want to connect the endpoint of the before spline. So grab a OR, and I want to connect it to the starting point of the guide spline. so. So let's connect it to merge by distance. Right, so we're down to 2 splines now because this point is connected. Right, for this point, let's duplicate the merge by distance and drop it on here. What we want to do is connect the endpoint of the guide spline, grab an OR, to the starting point of the after spline, like so, and connect it to selection. Right, so now we end up with one spline, which is this huge, well, long spline right there. Okay, now all we have to do is trim the spline down to the part that we want to show. Okay, so let's grab a trim curve, drop it right here, and change the mode to length. Then I'll grab a map range out of start, and I'm gonna duplicate it and connect it to end as well, like so. Just make some more space. Let's grab a value node and connect it to the value of both of these map range. Let me just connect like so. And let's start off by 0, which means, well, this is going to be the initial value. So let's figure out where the start and end points should be. To do that, we want to change the to min for each of these. So let me just grab and increase the to min of the end point. Okay. So this is where we want to start. So we want to start with S, then transform it to B. So this is the initial values for to min, both of these guys. So start to min is alright with 0, and the end to min is going to be 2 point whatever. This is going to be the length of this S, so the before spline. So what we'll do is grab a line out of here, just right before curved mesh of this before spline, and bring it all the way over here. Sample index, and let's sample the spline length right here. Okay. And let's connect it up to to min, like so. Okay. So this is good for the initial values. Let me just reroute so it looks cleaner. Right. Next, we'll set this value to 1 to figure out what values we want as 2 max. Right. So let me increase the end to max to where we want to end up at. So this is where we want to end up at, right? So we want to be showing the B, and the start to max should be right here. Okay. Right, so what are these two values? Right, let's start with the end part. This is actually the entire length of the long spline. Okay, so this is going to be just a spline length. Okay. Right, this value right here that goes into the start is gonna be actually the spline length minus the length of B. Okay, so let me just duplicate these guys, this one as well, bring it up, and let me draw a line out of here, the after spline portion, before the curved mesh, and connect it up like so. Okay. Okay. Now let's subtract these lengths, then plug it into 2 max like so. Okay. Now, if I were to change the value from 0 to 1, you can see the S changing into B. Alright. Alright, let me just clean it up a bit. How do I want to do this? Let me move it up. Let me move it that way. Okay. Next, I'll delete this value node and replace it with a group input. Reconnect, open up the side panel, go to the group tab, and I'm going to rename this input to factor right there. Okay. Alright. Let me just squash it down a bit because the node tree is getting huge. Okay. Right. So we've done it for one spline. So we want to repeat this process for the rest of the spline. So let me do it in full window. Right. So we'll add a repeat right here and split it apart like so. Go to the right, reconnect the group output, and add a join geometry right here. Then connect the trim curve up into join geometry. Make sure you select the bottom position of the socket. There's going to be 2 of them. And go all the way to the left. And let's connect the iteration to B. Like so. Okay. I'll clean it up. Alright. Okay. Alright. So, what are we going to use for iterations? Well, we want to iterate as, well, the number of splines that we're required to do. So, in this case, we have to do twice. We can get that number automatically by grabbing the guide input, get a domain size, change the component to curve, then get the spline count and plug it in right there. Okay. Right, I will be showing this at the end again, but this is what the morphing logic looks like. So let's tab back out and call this morph text. Okay. Now, if I were to change the factor from 0 to 1, there's going to be 2 splines coming out. That forms a B. Okay. Right, let's quickly animate this. I'm going to grab a float curve out of factor. And I'm going to change the curve like this so we have a little bit of change of pace. Then I'm going to add a map range and set the from min value to 0.1 and from max to 0.9, so there's going to be a little bit of pause when the text is formed. Draw a line out of here, get a fraction, so we'll always repeat when we'll be repeating the process. Then we'll grab a multiply so we can control the speed. Then we'll connect it to scene time. Like so. Okay. If we run the animation, you can see the S forming into B and repeating while it's there's a fraction. All right. Let's go all the way back to the left and change the string so it's a little bit more complex. I'm gonna have Bob/n, cat/n, then Tom. And I'm also going to change the line spacing so they're gonna be morphing in the same position. Okay. I want to make sure that we can iterate through multiple lines, so let me just bring these two nodes, so scene time and multiply, and connect a floor, then connect the result of floor to the top B of the separate geometry, and add one to the bottom B, like so. Okay. It looks like this now. Right. So let's run the animation. Bob goes into cat, and cat turns into Tom. Then it goes to nothing. If we want to loop the animation, what we can do is create some space here. Grab a noodle out of line, connect it to attribute statistics, and plug it into attribute. Plug the curve instance to geometry, change the domain to instance. From max, add 1. Then add a floored modulo after floor, and take the modulo with the result of add, like so. And we'll do the same for the bottom. Take the floor module, like so. Okay. Right. So, if we go back and run the animation, we have Bob turning into cat, turning into Tom, then back to Bob. Right. So we got the looping animation going on. So at the final portion, we'll turn it into mesh. So let's grab a curve to mesh. For profile curve, let's grab a curve line. Set the start to -1x, end to 1x, and set the z to 0. Then add a set curve radius, and set the radius to 0.01. Okay, right now we have this ugly corners, which I'd like to clean up. We can do that by adding a set spline type and turning everything into NURBs. So we now got this beautiful rounded corners, but just be aware that the vertex count or the poly count is gonna increase significantly when we do this, right? So it's gonna be about 10 times as much. So just be aware of that. If you're not taking a close-up, or if you're not, it's not a close-up scene, then you probably won't need this. But I mean, this is gonna make it much cleaner. Right, so let's take a look at the end result. I'm not going to be going through any materials today, so let's just look at the animation. So Bob turns into cat, Tom, then back to Bob, and it repeats. Okay, great. So let's take a look at what we made after I do a little bit of a cleanup. I'm trying to make it as clean as possible, but it's a little bit complex algorithm, so I'll try my best. But there we go. Right, so this is the top layer. What we're doing is selecting which lines to morph. We're matching the spline count, we're retargeting the splines, then we're morphing and converting into mesh. Right, let's take a closer look from the left. Here we go. Alright, so let's take a look at the retarget spline. This is a retarget spline. We're retargeting the control spline into the letters right here. Next, the morph text. This is the core of the morph algorithm. It's all in one big loop of repeat, but what we're doing is we're making the guide curve. We're connecting all the splines into one, then we're trimming it down to the necessary portion of the animation. Okay, closer look. Here we go. From the left to the right. Okay, this is where we make the guide spline. Okay, we're converting into Bezier and we're adjusting the handles and we're cleaning up. This is the helper function to identify where the starting and ending points are. Okay. Alright. Okay, so that's it for today. This is a Spline Morph. It's a pretty nice effect. Of course, you can do some clever things with materials. You can play with the fonts, and you can also play with exit and entrance points and make some more modifications. So I hope you get a chance to play with it, and see you next time.